You've probably heard that to build smarter AI, you need perfect, squeaky clean data, right? But what if that's totally wrong? Today, we're going to dig into some really fascinating research that uncovers a wild secret. The key to a smarter, more robust AI might actually be, well, a little bit of messiness. Okay, so let's just jump right in with a thought experiment. An AI has learned from, basically the entire internet, that the capital of Argentina is Buenos Aires. That fact is locked in its memory. But then, you come along and give it a prompt that says, the capital of Argentina is Beijing. So what's the capital of Argentina? What is it supposed to do?
And that's the core dilemma, right? If it trusts any new piece of info you give it, it's incredibly easy to fool with misinformation. But if it just stubbornly sticks to what it was trained on, it can never learn anything new or correct its own mistakes. It's a really tricky balancing act.
To really get how an AI tries to solve this, we first need to understand the two basic ways it holds on to information.
So you've got two types of knowledge. On one hand, you have parametric knowledge, or PK. Think of this as the AI's deep, long-term memory. It's all the stuff that got burned into its brain during training. On the other hand, you have in-context knowledge, or ICK. This is temporary. It's like you handed the AI a little sticky note with some info on it right now. The huge question is, when that sticky note contradicts its long-term memory, which one does it believe? To figure this out, a team of researchers came up with this really clever experiment. They basically built an AI sandbox where they could control every single thing the AI learned. So instead of using the wild, messy internet, they created their own clean dataset of 50,000 fake biographies. Every person had a name, a birthday, a university, a major. This way they knew exactly what the AI was learning and, crucially, how it was learning it. Then they put this new AI through 3 key tests. First, could it just remember a fact from its long-term memory? Simple enough. Second, could it use a totally new fact from that sticky note, the context? And third, this is the big one, when the two are in conflict, how did it decide? This is what the researchers call arbitration. And what they found? Well, it's pretty remarkable. It turns out there's a very specific recipe, a set of ingredients for training, that teaches an AI not just to memorize facts, but to develop a smart strategy for deciding when to trust its memory versus when to trust new information.
And this recipe has 3 kind of surprising ingredients: repetition, inconsistency, and skew. And let me tell you, that second one, inconsistency, is where things get really, really interesting.
So first up is repetition. The researchers found that for an AI to build both its long-term memory and its ability to learn from context, facts had to be repeated. But not just copied and pasted. They had to be paraphrased differently within the same document, kind of like how you learn from reading different articles on the same topic. And what's so cool is the timing of it all. The ability to use new info from that sticky note that develops super fast. But building that stable, long-term memory, that takes way longer. The model actually has to build these things called attention circuits to properly store facts, and that just takes time. Okay, but here's the catch. And it's a huge one. An AI trained only on perfectly consistent repeated facts becomes way too gullible. It learns to always trust the sticky note, the new info, even when its own long-term memory is absolutely certain that the new info is wrong.
So how do you fix a gullible AI? Well, this is the part that sounds totally backwards. You introduce inconsistency. The researchers intentionally added a little bit of noise into the data. For example, in just 1% of the training documents, a person's birthday might be listed correctly in one place, but incorrectly somewhere else in that same document.
And with just that tiny 1% of noise, something incredible happens. At the beginning of training, the model still trusts the new info. But as its own internal memory gets stronger and more confident, there's this phase shift. It's like a switch flips. The model learns that the world isn't perfect, and it starts to trust its own well-learned memories over some random, conflicting piece of new information.
So problem solved, right? Well, not quite. This new skepticism can make the model a bit too stubborn. It starts trusting its own memory so much that it just ignores all new info, even for things it knows absolutely nothing about. It basically forgets how to use the sticky note.
And that finally brings us to our last ingredient, skew. All this means is that the training data needs to look more like the real world, where some facts are super common and others are incredibly rare.
I mean, just think about it. An AI is going to see facts about someone like Albert Einstein thousands, maybe millions of times. It's going to be super confident about that stuff. but it might only see a fact about some obscure historical figure maybe once or twice. Its confidence there will be really low. This unbalanced distribution is called a long tail, and it turns out it's absolutely essential.
Because when you combine all three ingredients, the AI develops this really wise, nuanced strategy. For common knowledge, stuff it's seen a lot, it defaults to its own highly confident memory. But for rare, long-tail knowledge, it correctly realizes, hey, I'm not so sure about this, and it stays open to learning from new information you give it in the context.
So let's just tie all this together. The massive takeaway from this whole experiment is that our obsession with having perfectly clean data might actually be holding us back.
And the researchers themselves put it perfectly in their paper, saying that things we usually see as defects, like a little bit of inconsistency or an unbalanced dataset, are actually beneficial features that teach the model how to think and reason.
So the bottom line is this: a perfect dataset can actually create a flawed AI. A little bit of messiness, some errors, some imbalance, that's vital. And it means that this whole industry practice of aggressively cleaning and deduplicating our training data, it might be making our AI models less robust and less able to actually reason about the world.
And this isn't just some theory from a controlled lab experiment. The researchers double-checked their work against real-world models, like the open-source Pythia 6.9b, and they found the exact same patterns. This is really happening inside the AIs we use every single day.
So in the end, it all comes down to that simple three-part recipe. It's not about perfection. It's about repetition to build memory, a dash of inconsistency to teach some healthy skepticism, and a skewed distribution of facts to teach it nuance.
Which leaves us with a pretty deep final question. If building a truly intelligent system actually requires us to embrace imperfection, noise, and imbalance, all the things we've been trying so hard to get rid of, what does that tell us about the future of creating artificial minds? It kind of suggests that the path to smarter AI looks a lot more like our real, messy world than we ever imagined.